Okay, so everyone, hi, this is Michael
Hello.
Choi from civil engineer and fourth year, right?
Yes.
Fourth year. And I'm gonna show Michael how are we gonna find the maximum bending moment in a concrete column with indeterminate joint at both ends. I'm not gonna show you the process, but I will let you all know the result.
They're all joined together.
Yeah, they're all linked. That's the power of this parametric thing. So basically, if it's a pin connection, we just
Yeah.
need to move this point so that this point N and point K, they're flat because they're all zero.
Oh, okay.
Yeah, so it's
so
the
they
same
have to be
slope
on
as the
same.
B.
Oh, okay.
And then finish drawing. Well, I mean, giving him an example of what we're gonna do. So basically, it's a beam that has 20 in length, and then two pointed loads, which is 2000 and then 2500. Sorry, and then the force scale is 500, and then by using the graphic method. Here we have a negative moment at the top because the corner of the beam needs to stay at a 90-degree angle, and then we have a positive moment and a negative moment, and then on the right is the weird triangle stuff, and then in the end we found this is the H height and then this is the H force. And then we found out the maximum bending moment in this indeterminate concrete beam is 5,605.96, and I think the deflection point should be about the same. Right position. We can only make an approximate guess at this point, but yeah, let's listen to how Michael thinks about this graphic method.
So after hearing the explanation and how you plot everything, I think it's a pretty useful skill. It's pretty awesome that you can get a rough estimation for the maximum moment for an indeterminate structure just by graphing, and I think that's a pretty useful skill that they should start teaching in any of those engineering classes, because that'll be very helpful for structural engineering.
Yeah. How do you usually determine indeterminate connection? Like algebra, and you need to use different equations to do that.
So we haven't really dealt too much with indeterminate problems. Most of the practice problems that we do in class are determinate, and so I'm not too familiar, but I'm sure that we do not do it graphically. I think we are given equations and we have to solve for reactions or
Yeah.
some other thing. Yeah.
Yeah, I totally agree. Yeah, it took me a long time to understand how this stuff works, but thanks to Professor Edmund Slickis, we get in touch with this knowledge, which is actually from 18th century, like someone, I think that's what he said, like someone came up with this graphic method that a long time ago, and I knew my professor is using a textbook that hasn't been published yet, and I'm like, oh wow.
That's impressive.
Okay, so this is the interview, and these are the results, and yeah, and thank you, Michael,
no
for
problem.
helping me out.
Yeah, thank you
and
for showing me.
Yeah, and that's it.